Hi, this is Yosna Krishna Reddy. I'm going to present a project. Today I have taken the time series dataset. The overview of dataset is the weather forecasting dataset. It is designed for the developers who um, who want to train the models for Indian climate forecasting. The dataset which span from January 1st to April 2024, 2017, Delhi, India includes for critical parameters meets humidity and wind speed and measure mean pressure. Acknowledgement of this dataset. The dataset was obtained via the weather and ground API and credits and ownerships or ratherly um, there are assignment from an assignment for it is related with a data set which must be submitted by this and any submission has been uh, diverse. The submission of first report data set is the detailed report on the data set contains the following key information: weather forecasting data type is numeric, and the official website which I have taken this data set is from a Cogil, and the time span is from January 1st to 2013 to April 24, 2017, and the data points are variables. And if you are data organization, the mean temperature, humidity, wind pressure, and the mean pressure or on the parameters. The weather forecasting dataset provides the developers with an individual uh, opportunity to immerse themselves in the complexity of the weather forecasting algorithms. This dataset offers an important resources of individuals wishing a research and understand meteorological conditions in this specific geometrical location by the providing a rich and complete set of data converting the from January 1st to 2013 April 2024 to in Delhi, India. The model train possibilities. The dataset can be used by developers to train and refer whether the forecasting models, the many factors which is include mean temperature, humidity with speed and mean pressure allows for the developers of models capable of capture the indicates of daily climates during the selected time period, the climate understanding insights. The data set is more than simply numbers. It indicates a real world uh, um, observations that sheds lights on the delights of daily climate, and developers can extract important parameters and trends depending of this understanding of how various components interacting to shape the weather capable of predictions. The developers can improve their predictions powers with the dataset. They can be considered model capable of forecasting future climate conditions in Delhi by evaluating history weathers to data. This predictive capability is crucial for the various of applications, including the urban planning and predictiveness. Therefore, this is the regional character. We are going to see now the regional characters. The focus of Delhi, India address a degree of regional disintegratives to the data set. Developers can customize their models to match the specific weather patterns and considerations. This plays assurance. The educational impact. The dataset has a educational values based. It was created a part of these assignments of data set of University of Bangalore. Development can profit not only the data itself but also can insights the approaches conditions in generation in the academic sense. In the conclusion, this data set is great resources that extends behind data points. It acts as a potential for developers to enter the field of weather forecasting, allowing them to obtain profound insights, refined predictions model that contributes to awareness in understanding and anticipation meteorological conditions in Delhi, India. And now we are going to see the part two overview of NN simple neural networks. A simple neural networks in a neural networks is a specific architecture built for a sequence data process, RNN, as opposed to a stand feed forward. Neural networks includes a memory components that allows them to store information from past inputs. This memory is stored in the context of simple neural networks by the single hidden matrix. And the below is a architecture diagram for this. And now we are going to see the architecture. A simple neural network architecture consists of single hidden matrix H, and that serves as memory units, a vector matrix H, and this is a vector matrix H. Here, net is another name for it. The unlike a one-layer neural net, which can only refer a single previous hidden matrix, a simple uh, neural networks may consider several previous hidden matrix, making it more vers- versatile. And now the neural network cell that is simple. Now we are going to see the neural networks for these conditions. A simple network is also known as vanilla neural network or an Elman neural networks in honor of Professor Jeffrey Elman. The simple neural network which stores a memory and allows sequential learning is the important concept. This cell is essential for the processing sequence data, making it essential useful for time series prediction and neural language process and its recognition. And now the design condition of design here we consider, while the simple neural network includes this selection of hyperparameters such as the number of neurons in a neural network layer, the input pattern which represent the historical data points plays an important role in the designing the architecture. Furthermore, the successive layers, including a fully level, contributes to the overall neural network structure, creates a sine waves. Now we are gonna see this creating a sine waves. To be a project, a sine wave dataset is created, which is a source is a foundation for the further model training. This entails determining the characteristics such as range and data points counts. A data set with a 768 data points spanning from 0 to 50 is constructed using a numpy's rooms operators. The sine wave dataset is found by the associating each data point that with a sign value. The time series analysis application. The simple neural network uses a time series analysis to capture a temporal trends and depends within the sequence data. The qualifiers in it for jobs in which understanding concept of previous observations is critical for making a correct predictions about the future data points. Drawbacks benefits and drawbacks. While simple neural networks having advantages in the advantages in sequential data, these they also have a drawback such as difficult in learning long-term dependencies, and issue known the gradient problem. These features are critical for conducting the training and simple RNN for a specific dataset. Now we are gonna see a data preparation. Here the results resulting the dataset is splitting into a training dataset with about 20% set aside from a training. Standardization is used on the data to bring it inside is certain range using a min-max scaling, which is an important step in the guaranteeing uniformity for effective model training. The step up for a time series prediction. The dataset is further proceed for a time series prediction, yield input and output set for a forecasting future values. Series length of 50 is chosen and the data is structured accordingly. This stage established the groundwork for training neural networks to predict a future sine wave points. Create a neural network model. Now we are going to create a neural network model by using the uh, Python coding, the Kern's API is used to create a RNN model architecture. These two layers is in a model, a simple RNN layers with 100 neurons and the fully connected layer to aid a successful learning, and the important pattern with consisting of a 50 hierarchical period is a model in a 2D space. RNN model training. A generator is used to train the model, and a train series generator is used to inject the input in the stages. The training procedure uses multiple epochs and involves the learning from small areas of the data set. The optimization less function in mean square errors. The test data evaluation after training the model is associated on test data using a forecasting approach. The predicted values or compared to the actual values, and the results are paragraphed. The graph's neural zone reflects the actual values, while the yellow line shows the expected values. Now we are going to see the part 3, the neural networks. RNN LSTM neural networks and submit. Now we are gonna see a first question in that, the question of vanishing gradient problems, and the second question is with explaining the explorating gradient problems in the mid 1990s. Greenman scientist and the is a various he brings a solutions to the vanishing the gradient problems, and the LSTM neural networks can cause significantly more precedents fall by reminds errors throughout the back propagation path with throughout time and layers. A neural networks could study through a number of time steps. The basic concepts of LSTMs are cell states and grades. Now the because of vanishing grade issues in a relatively benefit memory, the simple neural networks has a limited limitations that LSTMs could address. Now, here is a small cell that of LSTM in consisting of a head state or secret key on the LSTM cell approaches to high C state, also known as the cell state. Now we're gonna see the second one in example of the cell state. In each time step in the series, the cell state can memorize the information based on previous event. It consisting of critical information such as weight, base, and minimum values. Using a many neural networks in this short period of time can improve the accuracy. This assembles a strategy, enter building, integrating, or averaging the multiple neural networks to enable more thoughts, a designing making process to cost functions, which relates the neural network performances. Now we're gonna see the vanishing and exploring grades of case study. Now, first case study, when the disappearing gradient, when the tan achieves function is close to a 1, but a long sequences in the results of vanishing the gradients have post weight updates, and then network long saltines. Now, second one is gradient explosion. When the tan derives is 1, the weight is too great. The gradient increases quickly, creating instability. This gradient exploration hampers effective learning. Discuss the limitations of simple neural networks. Here, the neural network architecture, and now we're gonna see the short-term memory. Simple neural networks are limited in their ability to remember information over lengthy sequence based to the vanishing gradient. As a result of the short-term memory effects, it is a difficult to capture relationship in the sequence with the huge temporary logs. Difficulties capturing long-term dependency. The neural network has difficulty capturing relationship between the distant steps and impacts of earlier inputs and less of as a sequences gradients. These are the gradient vanishing and exploring and input sequences and limited capacity of complex patterns and lack of gradient mechanisms and training difficulties. And then the conclusion of this is while simple RNA are simple and they're easy to design, their limits in the dealing with the long-term dependency and gradient reserve issues make them less suitable for the certain complex tasks than a more advanced recurrent architecture. Now we're gonna see the next question how the LSTM neural networks can provide a powerful solutions to the both gradients of problem. Now we're gonna see vanishing and exploration and we are gonna address of a simple neural networks and now uh, LSTM neural networks empowerations overcoming the vanishing gradient. The memory cell mechanism accomplishing memory cell mechanism used by the LSTM to address the vanishing gradient problem. Unlike simple RNN, LSTS has a memory cell that can be stored data over extending period of time. Here is the small diagram of the LSTM, how it changes the stages. The mechanism of grading. LSTM can be controlled the flow of information by using a gradient method such as grade and now we can see these methods like mitigating, explorating gradient, lengthy term dependency, and then gating mechanism in detail, understanding the complex patterns, and adaptive training. And then now we're gonna see the part 4 RLM LSTM with a time series data set. This is a simple architecture of LSTM with a time series data. Now, in the paragraph in this project, we will use the specific data to train the um, long short-term memory neural networks to forecasting a stock values. The main goal is to use the data temporal relationship to produce accurate future forecasting based on the prior stock prices. The important steps in the design, training, and associating the LSTM model are outlining in the architecture. Now we're gonna see data collecting and preparation. A stock price data set of 1183 data points was chosen for this study, standing processing procedures such as normalization and scaling were used to prepare the data for the LSTM training. In addition to that, 10% splitting of the data has been set aside for the testing. Now, neural network layer. The LSTM network is carefully constructed with a numerous characteristics in it. It is made up of two LSTM layers, each with a 25 neurons to prevent overfitting. A dropout layer with a 20% dropout rate is included. The time series data set input sequence length is set to 1183, which corresponding to the total number of data points. The Keras sequential API is used to build the model architecture. Now here the two LSTM layers are followed by the dropout layers for recognition and dense layer for output. In the design. The Adam optimization is used and the less function is mean square error applications. The dataset is divided into training and test data with the 90% of data used to train model, and the LSTM model is built with the Keras and the training model consisting of 100 epochs with batch size of 32. The reserved testing data is then used to evaluate the model. Then a model association. The testing phase evaluates the model performance on unseen data, and the results are examined to determine the LSTM neural networks effectiveness. The model is also retrained on the complete dataset to capture the board trends and its forecasting ability are proven. The outcomes of this data set and this project is the success of the project is determined by the associated model accuracy and the test data, retraining it on the entire data set and analyzing it is a pre-detection performance. The visualization and the matrix obtained during the test, retraining, and forecasting provide information about the model prediction. Finally, the LSTM model and the prediction stock values with a good results. It is performs could the performance could be improved with the more refining such as hyperparameters optimization and a future engineering. The the experiment demonstrates the utility of LSTM networks for time series forecasting applications. Now we're gonna see a part four, redesign the neural networks. The introduction to this project is LSTM neural networks for a stock price forecasting. The goal of this project using a stock price is to develop a train, evolute, and LSTM memory. The neural network for stock prices forecasting because the final markets are dimensional and predictable forecasting stocks values in difficult understanding. Neural network design elements. The following data set was used to capture the varied market circumstances. A comprehensive stock prices dataset was chosen. The percentage to the test is 10%, and the number of LSTMs is to be probably captured. Temporary dependency. The neural networks design is considered of two LSTM layers. The number of neural networks in each LSTM layer is followed by LSTM layer consisting of 50 neuron allows the model to understand complicated patterns in the time series data. Dropout layers with a 20% dropout rate is inserted into the network to prevent overfitting. Now, the time series input length. A sequence length of 1183 time series is chosen to prevent the significant historical context for a model, and the batch size for the training. A batch size of 40 is used during the training phase. Balance computations affects with a model optimization. The batch size for the testing. The batch size is set to a 1 for reorganized testing to evaluate a model performance. The architecture model. The LSTM architecture neural network. LSTM neural network architecture is carefully designed with the two LSTM layers to facilitate the capture of long-term dependency. The addition of the dropout layer improves the model uh, gen- generability by reducing the outfitting. The duration of the input sequence is carefully set to a 1183 to cover a significant time span. The time the time procedure is this sorry the training procedure. The model is trained using a supplied parameters, which is including a training testing and percentage to establish a balance between effective weight optimization and computational efficiency. A batch size of 40 is chosen for the training, evaluate, and testing. After training is completed, the model is thoroughly tested on the chosen data set. Mean square error and other evaluation metrics are used to measure the model predictive performances. Visual comparisons of expected and actual stock prices reveal extra information outcomes. The result selection provides an examination of model performances, including the training testing model, visualization, and noteworthy findings. Now we're gonna see part six, the report for the conversation of analysis. The LSTM neural networks parameters are just introduction. This research provides a detailed comparison of two LSTM neural network designed for stock pricing. In the original model of part 4 is pawn stack compared to the rebuilt version of Part 5, which incorporates many parameters, twists, aims at improving overall performance. Just to comprehend two parameters, as seen here, we need to adjust the parameters accordingly. And then now we are gonna see impact of the increasing the test data percentages. Increasing the test data predict percentages gives a more comprehensive evaluations of model performances on unseen data. However, it is critical to consider the potential less loss in the training data. The neurons per LSTM layers impact. The increasing the number of neurons per LSTM layer seeks to improve the network's ability to detect the complicated patterns in the time series data. These changes is intended to increase the model learning and generation skills. Increased dropout rate impact. Increasing the dropout rate helps to improve the regularization during the training phases, minimizing the overfitting and improving the model adaptability to new data. The training batches size um, impacts the increasing the training batch size aims to allow a more efficiency way adjusting the throughout the training. A bigger batch size can be lead to a better conversation convergence training success. The impact of the extending the training epochs. This extend the training epochs gives the model more iterations to alter its weights based on the training data. This expansion anticipated increases convocations and overall training improvements. The conclusion of this is the comparative analysis shows the neural networks includes a significant parameter changes that was carefully chosen to improve overall performances. These changes aims to improve the model's capability, recognition, and training efficiency. The full impact of these changes demands extensive testing and confirmation of the relevant KPIs. Now we're gonna see a part for um, the part 7, the project report. This overall project report was mentioned below. To introduce the project introduction session, here the RNN or the short of neural networks in which the outputs of one phase is used as input of the subsequent phase. Standard neural networks has inputs and outputs that are completely independent of another one another, but it is some circumstances such as when predicting the net word in the sentences, the predicting words must be remembered as a result. The RNN was created and it was a hidden layer to overcome the problems. Now the goal of this LSTM recurrent unit is forget unnecessary data while remembering all of the neural network prior information. This accomplished by incompleting various grades or activation or function levels of various applications. Furthermore, each LSTM recurrent unit keeps an internal cell state vector, which basically summarizing the data that the unit before it decided to keep. These two items are then moved to the next concealed layer. In the contrast of RNN, which only have one TAN layer, LSTM have a three logistical sigmon gates in the addition of one TAN layer. Um, Gates are used to limit the amount of data that can be entered as a cell. They decided with the information is needed by the next cell and which is rejected. And now we're gonna explain what the student did in part 2 and the part 4. Sorry, now we have did in the part 4, part 2 and part 3 and part 4, part 5. In order to generate the predictions outputs for sequential data that behaves like the human brain, we must take into account and point out the pinpoint data correlations and patterns for a time series forecasting. In the part two, on the other hand, an RNN should be able to recognize the word, but terribly the exciting, and after reviewing the full sequences, the phase that moves from negative to positive, read the entire sequences gives with the context for a comprehensive of significant. Now we're gonna see a description of model simple RNN on LSTM and what we have worked here. A memory cell is decided to the memory cell in the RSTM units can be stored data for extending period of time. When the neural network must flip between the recent input and the historical data, LSTMs are especially beneficial for the predictions. A short-term memory bias as a difficult with a recurrent neural network. For example, if the bear and the fox were placed between images of a flower and tree, the domestic or nature, the neural network would struggle to retain their importance. To put it simply, RNN are not well optimized using the storage strong long-term memory. Now, finally, the project closure, we learn about the Ornan, it merits and the drawbacks, and how LSTM benefits for the trackle and trying test and data set, and drawbacks of a simple RNN models via this project and the codes. The term of fancy RNN refers to LSTM. Vanilla RNNs are RNNs that do not have a cell state, they only have a hidden state, and the RNN store information in the in this hidden states. LSTM, on the other hand, contains both cell states and the hidden state. When depending on this on its status, information can be added to or detect from a cells which is grounded by the gray. Because of this cell, the LSTM can be able to deal with the long term relatives. Thanks for your time.